Welcome back to the SmallSat Revolution podcast, powered by GomSpace. I'm your host, Frank Falker. Today, I'm bringing you a unique guest that I met at the Satellite 2024 show in Washington, D.C. Jean-François Morizur is founder and CEO of Cailabs, a French company that uses proprietary optical technology to provide broadband speed data transmission from satellites to ground stations here on Earth. I think you'll be interested in what Jean-François has to share. Welcome back to Satellite 2024. I've got a very interesting guest for you right now whose company is doing some great stuff. Would you be kind enough to introduce yourself?
Hi, I'm Jean-François Morizur. I'm Cailabs CEO. Cailabs is a company about 100 people based in France, in Rennes. We've got offices in Washington, D.C. also. And we do optical ground stations. So, yeah.
That's great. And I was just learning more about your company and your technology. And it's fascinating what you guys are able to do with lasers and the amount of data that you're able to download from satellites to ground stations. And then I guess once the data comes down, it goes off over fiber optic, or where does it go from there?
Definitely. So you put the ground stations in many places. It can be on a military base, then you use it there, or it is on a network node, and then you ship it with normal fiber. In terms of sheer speed, you can get a 10x or even 100x depending on what you compare it to. So typically, SDA standard today is 2.5 gigabit per second, so it's quite conservative. You could achieve that with RF. There is quite a lot of terminal going to 10 gig, so then it starts to be more difficult, very much more difficult to do that with RF. And then the 100 gig crowd, including Starlink, for example, this is extremely, almost impossible to do with RF. So you get this kind of increased bandwidth at no extra cost. It's roughly the same.
Wow.
On the ground segment as a normal RF antenna. And my understanding from information I've got is that for the spaceborne stuff, it's the terminals in sky are roughly equivalent, maybe a little bit cheaper when they're optical than when they're radio for the same kind of bandwidth. Interesting.
And I would imagine, please correct me if I'm wrong, that the applications for this are as multifaceted as their applications for satellites, as far as Earth observation, security, military.
I agree. What's interesting is that what I believe is the places where optical communication will be a strong benefit compared to radio. Are not going to be. It's not going to be everywhere. It's not going to be like 10% of everything. It's more going to be like if you want added security, you will probably look to optical very early, because when you look at added security, the link and laser link is very difficult to intercept, very difficult to detect. So they call it LPD, LPI, low probability of detection, low probability of intercept, compared to a radio beam. So you want to go there if you've got a sovereignty question, a defense question. You probably want to move faster to laser than other fields. If you've got a very big amount of data to beam down, then of course high bandwidth will help. So it's likely that you've got Earth observation satellites that will be very interested in getting data down for cheaper. So that's kind of the other thing. The one drawback of optical is clouds.
Real clouds.
Normal clouds. Yeah, not the AI clouds. Definitely, I agree with you. So the clouds and fogs and dust storm or whatever, and so this means that you need either spatial diversity, so make sure you always have one ground station connected to your constellation. Then you've got OISL, or it means that your use case is tolerant to that. So, for example, your Earth observation, and you're downloading, and then you basically will download on the next ground station available. If the first ground station on your orbit is cloudy, that's okay. There's another one later, and you're going to download everything in one pass, so you're happy with that instead of waiting for multiple passes with RF. So this is kind of thing that you need to think about. How do you deal with this kind of meteorological phenomenon that you don't have with RF?
And in what stage of development are you in? This is existent technology that your clients are using today?
So today we, Cailabs, we do ground stations. We are quite specifically, we came to that field because we had a way to deal with turbulence. So to deal with the impact of the laser beam when it goes through the atmosphere, it is a little bit scrambled, speckled, and if you don't deal with that, you've got a problem. So this is our kind of the very strong capability that nobody else has on what we do, and this makes our ground station a little bit special. At the moment, we sold quite a few, 5 last year. We delivered one, so it's still the beginning of the market. So it's still like the people are using it, yes, but not in high volume. And it's moving fast, and it's very interesting.
Well, the reason why I asked specifically if it's being used now, is it available for new clients to purchase?
So it is definitely available for new clients to purchase. It is, and we on our side we are growing the capacity to be able to manufacture them. The bottleneck on our side is basically being able to test them before we ship. So we have to mount everything, do a factory acceptance test, usually with a satellite to test that, and then we can ship. And then so that's kind of we are scaling that up in order to be able to meet the demand. Yeah.
And is there any significant training required for the client in order to engage with your tech?
It is optical. So I've heard of situations where some academic ground stations or experimental ground stations were deployed within teleports with RF antennas, and people would handle the RF cabling in the same way they would handle the fiber cabling. That doesn't work. Okay. So you have to. There needs to be some training. It's not crazy or impressive training. It's like there needs basic training on a fiber is more fragile than a copper cable. There's some things that are easier, like all the things that with basically electromagnetic sensitivity that you've got with antennas. We don't have that for optical, so there's some things that are easier. Security-wise, the ground station are all eye safe. So you make sure that this is SDA was pushing in this direction, like everybody's pushing in this direction, like making sure that your ground station is eye safe. So you don't have any safety issue with the ground station themselves for the people around them, but you need to make sure that the technicians are trained to handle this kind of optical system.
Keep themselves safe.
Exactly. Not really keep themselves safe, but keep the system safe. The system is built, yeah, exactly. So how it's simply just cleaning the connectors, basically. This is very simple stuff, but you need to teach that. And so we do that, obviously.
Okay. And it needs to get done. Somebody needs to clean those things.
Not necessarily. It's more like when you do an installation, you need to connect everything. When you do connect any kind of, it's best practice to clean your connectors anytime you want to connect something.
Oh, it's not an ongoing maintenance technique.
No, not necessarily. Not necessarily. There are some ongoing maintenance related to the telescopes, but it's not the same thing. It's not something also you can teach, but it's usually. I don't see why you would have people just coming around and putting their hands on the telescope, while working on connectors. That happens all the time.
Okay. Well, what about? And I don't want to take too much more of your time. I really appreciate it. What sort of, as I would say, the low-hanging fruit for you? What are the prime verticals or applications that are best suited that will get the most value from your technology?
I believe that. Actually, you're asking two different questions, which is really very interesting. What are the low-hanging fruit for Cailabs, and at the same time, what are the verticals where they're going to get most value?
Okay.
And I think it's not the same answer for both.
All right.
Low-hanging fruit for us is probably like the markets where there's a demand very fast today is defense, sovereignty, because you get, they get the benefit of radio silent communication, very difficult to detect, very difficult to intercept, and this has many impacts on a range of use cases that are critical to the world today. Ukraine was a place where people realized that you cannot trust your radio network. There's a lot of scrambling going on. All that. So your intercept is possible too. So there's a realization that yes, for conflict we need the ability to communicate, if possible, in a protected way. And that's I think this is a very big drive on the defense sector to get this working. And the SDA in the US is extremely good at pushing it out, rolling it out, and with this kind of maintaining this kind of competition all the time, trench after trench. This is amazing what they're doing. So I think that's the first kind of answer is what are the first markets. Now, what is most impactful? I think if you think in terms of economic term, in terms of impact, those products at 100 gig, they are similar to, in terms of capacity, to what you get as a telecom operator.
Okay, no
the
kidding.
Operator. Mm-hmm. And so basically what it means is that you can think about a reshuffle of what it means to be a telco operator, what it means to bring data from one country to another. And I've seen, you can read through that, but yes, it makes it economically not crazy to think about connecting a country with this kind of thing. It's going to be down the line, but that's extremely impactful. You can imagine,
that's fascinating.
Yeah, you can imagine a new telecom operator that would say, okay, I'm going to project connectivity, internet all around the world, but instead of doing that with subsea cable, I'm going to do that with satellites. That's just, it changes a lot of things. So sensitivity we have to subsea cable that can be cut. You don't have that anymore.
Sure, yeah.
The ability to also serve countries that are not connected to water. So there's no subsea going there. You can do that. So there's a lot of things that can be done.
Absolutely fascinating. I'm so glad you took the time to speak with me. I want to make sure people understand how to learn more. And we can, of course, put graphics on the screen and website and that kind of thing. Is that the best thing for people to do?
For us, yes. Cailabs culture is we first off, we put a lot of things on our website. There's also, we're a French company. In our culture, we like to, and also from a scientific background, so we like to present things in conferences and publish papers and peer-reviewed papers and publish papers with partners. I think for us, it's a way to build credibility one side, but also to keep the standard up. Less PR, more actual data, basically. And so you can find most of our publications on our website. There's a link directly, scientific publications or engineering publications. And then we can find us at most of the conferences. We're going to be speaking like Photonics West recently, Ixos. We present some of our results, maybe not all of it. Sometimes it's a bit difficult. You have 100 people working. You cannot be exhaustive, but you can present stuff. Yeah,
I think that's a great approach. Open.
This is ours, basically.
I like it, and it will attract more like-minded people to you. More of the people who get the most value from what you do.
That's what we hope for. Yeah, exactly.
I believe it's true. Well, and so last question then: if they go to your website and they're searching for the publication and so forth, is there a contact us form or the contact information?
Yeah, obviously there's a contact us, and if you've got more questions, we are at most of the big trade shows for satellite. There's a presence for Cailabs, including Space Symposium coming up.
Oh, I was just going to ask you, so I'll be there as well.
Yeah, me too. But then on top of that, there's the contact us on the website, and there's a way to contact us there. Yeah.
That's great. Well, Jean-François, I really appreciate you taking the time to speak to me today, and I'm fascinated by what you guys are doing.
Thank you very much.
Thanks again to Jean-François, and thank you for joining us. If you found this content to be interesting and valuable, please follow us on LinkedIn, Facebook, and Twitter, like and subscribe on YouTube, and listen to our audio editions on a podcatcher near you. Until next time, I'm Frank Felker saying I'll see you in space. The Small Sat Revolution podcast is powered by GomSpace, with platforms, components, systems, and services to meet every small sat requirement. GomSpace brings their innovative technologies and a flight heritage of over 2,000 successful deployments to your next mission. GomSpace, leading the small sat revolution. Learn more at gomspace.com.